In this video we examine three different formulae for measuring the area of a triangle. The first is the old formula area equals half base times height. The second is a formula that you can use if you know two sides and the angle between them. Area equals half AB times sine C. And the third is called Heron's formula, and you can use it if you know the three sides of the triangle. Let's have a look at some examples. In this first one, we know the base and the height, so it's a case for area equals half base times height. Put the numbers in and it should work out pretty well. Don't forget that the units of your answer are in square units. This was measured in centimetres, so the answer is in square centimetres. The second example is also going to use half base times height, but it's important that you realise that height is always measured at right angles to the base of the triangle. In the case of an obtuse triangle like this, it's necessary to extend the base out so that the height can be measured at right angles. When we work out the area, it's still half base times height, so half times 4.2 times 4 will give us the answer here. The next questions use the formula area equals half AB times sine of angle C. When you're using this formula, it's important that the angle is between the two known sides. The first example is set up beautifully for this. You can see that the angle 28 degrees is between the two sides that we know. So area equals half times 6.4 times 7.2 times the sine of 78. The next one is not so well set up. We need to know the angle between the known sides. But we can work this out because the sum of the angles in a triangle is equal to 180 degrees. You need to do a little arithmetic to work out that the angle between these sides is 60 degrees. In the last questions you can see that we know all three sides of the triangle. This is a case where you can use Heron's formula. You'll notice that Heron's formula features the variable s. S is the semi-perimeter of the triangle, or half the perimeter. Let's see how Heron's formula can be used in the examples. First thing is to calculate the semi-perimeter by adding the sides together and dividing by 2. In this case, the semi-perimeter is 9. We then have to substitute it into Heron's formula and work through and calculate the area. The last example is very similar. We first have to calculate the semi-perimeter by adding together the sides and then dividing by 2, and then substitute that value into Heron's formula s times s minus a times s minus b times s minus c and take the square root to work out the area.